Hi, this time, as promised, I will demonstrate the use of a laser power meter and thermopile to measure the power in milliwatts of a 532 nanometer diode pumped solid state laser. Okay, as you notice, the goggles aren't sitting here anymore. I'm actually wearing them this time, so and I realize that I don't look cool, but I'll certainly benefit from intact retina and corneas, and be much happier as a result. So I've left the battery unattached because I wanted to show the startup sequence of this really nice laser power meter. Make sure you get a good angle. Okay, so it's showing 0 milliwatts and instantaneous and 0 max. So the laser is switched off. Now we're going to have to line up the beam on the little square that is actually the thermopile, but that'll come in a second. Let me go ahead and start it up. Okay. Alright, it's counting up. It's beginning to stabilize, but generally it takes about 15 minutes of operation before a DPSS becomes stable and the beam quality gets to its maximum. Nevertheless, we're well above 100 milliwatts. And when I originally purchased this module before modification and alignment of the optics, and before I added more indium around the KTP, it was actually only a 50 milliwatt laser. So in any case, oh yeah, you can see it's going up a bit. And it'll peak somewhere around, somewhere over 130. It has before in the past. But as it is now, it's bright enough for me. So if you're going to experiment with lasers, I don't care if they're 3 milliwatt all the way up to 3 watt. You know, you're going to want to wear the appropriate goggles for the frequency that you deal with. So, getting some good output. We're up to 133 now. And the way the thermopile works is it converts heat from the laser beam, and it takes that heat and applies some math with the microcontroller. And that result is calibrated, and you get a milliwatt readout. And there's other types of laser power meters that work on other principles, but that's simply put, that's how mine works. And I purchased it from a great guy on one of the laser forums online. I was pretty active in laser building and modifying for a while until I realized how expensive it was, and then I decided to kind of cut down a little bit. So that's how you measure. Let's see, now that the beam is removed, currently it's showing 0 milliwatts, but 134 max. Oh, and another neat thing about this particular meter is it has a pin line connector, and with an RS-232 on the other side, and DB9. So if you have a computer with a serial port, you can do data logging, and it actually, I have some software that allows you to do data logging with this particular meter, and it's really, really nice. It's very useful to have a performance of the. It's very nice to be able to graph power as a function of time. And that's what data logging gives you with this particular meter. So anyway, fun stuff. 73.